Welcome to this webinar on mastering coordinate geometry, circles, and polygons. My name is Saqib, and I'm going to be a host today. Most of you by now know me that I work with GMATWiz. I am the lead product manager at GMATWiz, and I love teaching quant. And our little endeavor through these webinars is to make sure that we help you as much as possible, and focus on areas where you might not be doing well. Okay, and today also the main purpose would be that to focus on certain geometry aspects, certain ways of solving geometry questions, certain important topics which might help you do well in geometry. As far as the progression of the session is concerned, it's pretty simple as usual, the same. The first is the main part. This webinar is divided into two parts. The first part is where I'm going to talk about geometry. What are the topics that you need to cover? What are the important formulas or properties that you need to know? And how can you approach a question? What are the things that you need to think while solving a geometry question? And I'll keep about 15 to 20 minutes in the end, depending on how much time we have. And if you have any questions related in general related to quant, or in general related to GMAT prep also, then I would highly suggest that you ask those questions at the end of the webinar. Okay. So that's about it. That's briefly about the way I'm going to conduct the session. So I'm going to jump right into it. There are a lot of things that I need to discuss, so I'll start quickly. First of all, I would like to talk about the important topics in geometry. I hear a lot of people come and tell me, hey, I don't like geometry, so can I skip it or just learn the formulas? What should I do in geometry? So what I've noticed in geometry, at least as from the GMAT perspective, is that there are certain things that you should definitely know. Right? You should know the basic properties of at least these four topics, like lines, triangles, quadrilaterals, and circles. This is how I categorize it into basic. Now, what do I mean by basic? By basic, I don't mean that these are easy topics. What I mean is that you should know the basics of these particular four concepts, and these polygons, basically, right? You should know what is the formula, how to find the area, what are the angle properties, diagonal properties, so on and so forth. Because in GMAT, there is a possibility that you might get a standalone question on these topics, and some of them might be just direct application of the formulas. So not doing geometry at all is, I would say, not a good option, especially people who are targeting, say, 46 plus or something like that in quant. I would say it's definitely basic should be done. Okay. After that, I would say there are certain things where you need to focus more on. If you notice, I've written mix of all topics. When I say mix of all topics, what I mean is I'm basically talking about, just one sec, guys. I'm basically talking about these topics, mix of all topics. Okay. So what I mean by that is in GMAT, what's going to happen is you'll see a lot of questions which are a combination of, say, triangles, quadrilaterals, or quadrilateral circles, right? Maybe lines and angles and triangles. A lot of questions where you get a mix of them, and that is where people face a lot of problem. Now, if you're really targeting a good score in GMAT, it is really, really important that you know how to approach these kind of questions. And I am going to take up a few questions based on that, where we'll be focusing on just this mix of topics only. Okay, I have one or two questions on this. After that, there is 3D geometry and coordinate geometry. In my experience, what I've seen so far is that coordinate geometry is a must. You would definitely get at least one question from coordinate geometry. 3D, maybe touch and go. You may get one, you may not get one. But at least coordinate geometry is something you will definitely get questions from. So it makes sense that you go through it properly. Okay, so the main takeaway from this is that make sure that your properties, basic properties are done. If you're just looking at, if you don't want to go through it fully and you're targeting, say, 46, 48, still fine. But if you're looking at a 48 to 50, for example, it makes sense to practice questions which are a mix of all topics and coordinate geometry and 3D geometry. Having said that, to do well in geometry in general, also, I believe you should, there are only two things that you need to be good at. One is knowing all the properties, because without that, believe me, you cannot do well at all. Okay, be it the basics or the advanced questions. Say if you don't know the formula for, say, the properties of the diagonal, say, for example, you will not be able to solve the question come what may. You may still forget a formula and maybe number properties and somehow logically get to the answer, right? Maybe forget the formula of say quadratic, some special properties of quadratic equations, still reason out the answer. But in geometry, that doesn't work that way. If you forget a formula, if you forget a property, there is a very low chance that you will be able to get it correct. So first thing, if you're going through geometry, is make sure that you make a cheat sheet of all the formulas, keep it with you, make sticky notes, learn it day in, day out, so that it's like second nature to you. Second, and the most important thing, especially for advanced questions, is the visualization, where I keep on forcing students to basically draw the diagram, even if it's given in the question, draw it on your own, mark all the information that is given in the question, and then try and solve questions. I've seen people just look at the diagram given in the question and not solve and not using it fully, or they're just without using pen and paper trying to visualize it. That is not what I mean by visualization. Visualization basically means properly actually drawing say every diagram, marking all the angles, marking the sides, so that everything is there in front of you, and then you can decide what properties you need to use to solve the question. This is really, really important, guys. Okay, so I hope this part is clear. If you have any doubts, please ask. So I'll pause here for a minute. I'll go and look at the chat box and see if there are any questions. Okay, so I don't see any questions. Some people are saying that my voice is breaking. So let me just put up a poll once again very quickly. Guys, I hope you can hear me clearly. If you can hear me clearly, please mark yes. Okay, I can see all of you can hear me clearly. So Tattva Vaishnavi, I would request you to look at your internet connection maybe, because I think everything is working fine at my end. Okay, great. So guys, this is what I wanted to talk about in general about geometry. So this is like non-negotiable, believe me, there's no shortcut to this. Learn the properties and work on visualization. So what I'm going to do is I'm going to take up so I have about 9 questions. I'm not sure if I'll be able to discuss all of them or not, but I'll be at least taking 6 to 7 questions out of those 9. And I am going to discuss some of the important properties that you should definitely know to solve geometry. Most of the questions are in the category of between 600 to 700. I have not bought any 700 plus level question. The reason being simple, because I wanted to actually show you how to approach the questions, and I felt it's best if I focus more on questions which are between 600 to 700 and not 700 plus. So I just wanted to make that clear now only, because a lot of you asked me about the difficulty level. Most of the questions will be 600 to 700. How it's going to work is I'm going to give you a question. I'll let you solve it, see whether you're able to solve it or not. And maybe if you're making a mistake, then what I'm going to do is in the solution part, I'm going to first cover a bit of theory, and some of them are really important. And then I'll show you the solution, actual solution. And I'll show you, if you know the theory really well, the concepts really well, then a lot of geometry questions can be solved under 30 seconds also. Okay. So maybe then you'll be able to appreciate why it's very important to know the properties. Okay, so let's get started, guys. I'm going to give you the first question. The process is going to remain the same. Okay, I'll show the question. I'll bring up the poll in front of you. Okay, I would request all of you to mark the answer in that poll and not in the chat box. I'm being very clear here. Please don't put the answer in the chat box. I'm not interested in that. Once you're done with the question, we are going to start the discussion. Okay, so if this is perfectly clear, please mark yes so that I can show you the first question. Okay. Okay, I can see that it's perfectly clear to everyone. So here's the first question, guys. And let me bring up the poll. So you have the poll, you have the question. All the best, guys. And I'll give you about 2 minutes to solve this. It's an easy one, should be done in 1.5, but I'll give you 2. Okay, guys, another 30 seconds and then I will end the poll. Ten seconds. Okay, I'm ending the poll now. Okay, I have an interesting result here. I'm sure you can see it yourself also. I have a 35% of you think that the answer should be C, and I have about 20-25% who are split between D and E. So as you can see, if there's some confusion regarding the property, the answers that you'll mark will always be quite different. And questions, believe me, questions based on diagonals are quite common on the GMAT. So it makes sense for you to know it. So let me first of all talk about the property. As I told you, I want to first of all tell you what properties you should know when you're dealing with quadrilaterals. Now, what I'm going to do is I'm going to spend about 5 to 7 minutes on this slide. You can either take a screenshot at the end, or I'll share the PDF with you. It will have all the properties in this, and it's very important that you take a printout of this of all these properties and keep it with you. Okay, so I'm going to discuss properties of each and every quadrilateral one by one, and I'm going to start by parallelogram. Now, what I want you as a student is that whenever you see a quadrilateral, you should be able to talk about all the properties of that quadrilateral really, really quickly. For example, if I ask you what is a side property of a parallelogram, you should be able to say the side properties are that the opposite sides are parallel. So in this case, AB is equal to CD, okay, and BC is equal to AD. You should be able to say that very quickly, okay. If I talk about the angle property, you should be able to say angle A is equal to angle C, angle B is equal to angle D. So these opposite angles, they are equal basically, this and these two angles are also equal. Okay, and the sum of this angle plus this angle, the sum of this angle plus this angle is 180 degrees. You should know these. There should not be any confusion regarding this. As far as the area is concerned, you should know that the area in case of a parallelogram is base times height. So as you can see, I've drawn a height here, which is AE, which is 90 degrees. It's not drawn here, so let me mark this as 90 degree. So the height is AE, the base is CD. You should know that the area is CD times AE. Perimeter is easy, obviously. But the diagonal property where most of you falter is that in this case, in a parallelogram, they bisect each other. Okay, so if I draw the parallelogram, and let me draw it here, I'll draw it very quickly. So if I draw a parallelogram and I join this, okay, they bisect each other. So this is equal to this, and these two are equal, okay. But the diagonals are not equal, okay. It may or may not be equal, and they definitely don't bisect each other at 90 degree. So that is something you should be able to remember or know. You don't have to think a lot or try and think, okay, let me try and derive it. That's not going to happen, just to be very frank here. Okay, now if you understand parallelogram, understand rectangles, squares, and rectangles, squares, and rhombus, they are special parallelograms only. Okay, so if you look at a rectangle, what happens in a rectangle is that as far as the side properties are concerned, they're the same as a parallelogram. Opposite sides are equal. The only difference is that you know the names. They have a special name like length and breadth, nothing else. But the property is still the same. Opposite sides are parallel. The other thing which changes when you come from a parallelogram to a rectangle is that all angles become 90 degree. Now, in case of parallelogram, the angles were not 90 degree. Okay, they could have been anything. But in this case, all of these are 90 degree. All four of them are 90. Okay, area in this case is the same as the parallelogram, just the name is a different. We call it length times breadth. Here we have to draw height to get it. Okay, perimeter is easy. I'm not going to into it, but the diagonal property is important. In case of a diagonal of a rectangle, please remember the diagonals bisect each other. They are definitely equal, but they do not bisect at 90 degree. So notice the progression. So when you have that in the form of a table, it's easy to remember. In a parallelogram, notice they bisect each other, they bisect each other. When you move from parallelogram to a rectangle, this changes because now they are definitely equal, but this is still not changing. Notice still not changing. But when you go to a square, everything, remember, a square is like every special property that you can think of works with a square. All sides equal. Okay. In fact, this is not written properly here. All of them are equal. AD is equal to BC. Okay. Uh, Obviously, all angles are 90 degree. The area becomes side square because all lengths are equal. Perimeter is easy, 4 times any one of the sides. And here, if you notice, in case of a diagonal, they bisect each other, they're equal, and they bisect at 90 degree. So notice the progression. If you remember this in this form, there's a good chance that you may not forget it. Okay. When it comes to rhombus, rhombus is basically a very special parallelogram where the sides are equal, but the angles are not 90 degree. Like in this case, in case of a square, these are all 90, all 4 angles. Okay, but in case of a rhombus, that's not the case. All the 4 sides are equal. Okay, but the angles are not going to be 90. In this case, they follow pure play parallelogram property. What I mean by that is opposites angles are equal. So these two angles are equal. This angle and this angle is equal. Okay, but they're not 90 degree. And whatever angle property that you have written in case of a parallelogram, whatever, they obviously the rhombus will also follow that. Okay, area in this case is half product of diagonal. So you have to draw a diagonal like this. Okay, let me rub this too, just to show it to you. If I draw it like drawing geometry is actually pretty difficult. But my point is that if you draw the diagonals, you get AC, you get BD, that is half product of diagonals. Okay. Perimeter is very easy, same as square. But here's what is interesting in case of diagonals of rhombus. Notice in this case, in diagonals, they bisect each other. So bisecting property will not go. Okay. But they are not equal. Okay, in rhombus, that's the only special thing that you need to keep in mind. In case the difference between a square and rhombus is the angles are not 90 degree and the diagonals, they are not equal. This is very important. If you forget this, you might end up marking the wrong answer, which most of you may have done in this question. But they bisect at 90 degree. Okay, so I hope you can see the differences that I've shown here. Obviously, trapezium is there. Thankfully, they don't test you a lot on trapezium. You'll see one-off question there. In trapezium, just only parallel sides. One pair of sides are parallel, as you can see. CD and AB are parallel. Sides may or may not be equal. Sum of angle obviously has to be. This is 360, by the way. This is 360. And since they are parallel, these two, this angle plus this angle plus this angle is 180. This is important. Sometimes you may have to use this. So in case of a trapezium, you should know half into sum of parallel sides AB plus CD multiplied by the perpendicular distance. So this is an important formula that you should be aware of. Perimeter is simply the sum of all the sides. And in diagonals, there's no special property. Thankfully, you won't be tested on diagonal property, but they do not bisect each other. They are not equal, and they don't bisect at 90 degree as far as the general trapezium is concerned. So guys, these are the main properties. Now, if you want to take a screenshot of this, feel free to take a screenshot. Whatever editing also needs to be done, I've done it here. But if you remember these, solving the question which I gave you before will be very, very easy for you. Okay. Now, if you have this in front of you, if you have taken a screenshot, let's go to the question and see how quickly, if we know the property, we can solve the question. Okay. Now in this question, I've been asked whether the quadrilateral is a square. Okay. I now know all the properties, assuming that I know it. I'll go to the first statement. I'll see that it's given that the diagonals are equal. Now, if you remember the properties properly, you'll be able to say, okay, diagonals equal. I know that the diagonals are equal in case of a rectangle. It is equal in case of a square. Okay, but the question's asking, is it a square? Well, I cannot be sure. There are two possibilities. So this is not sufficient. It will hardly take you 10 to 15 seconds to make this inference. Second statement, diagonals bisect at each other 90 degree. Then I'll say, okay, bisect 90 degree. There are two quadrilaterals like that, square, rhombus. So can I answer my question? Is it a square? No, I cannot. So this is also not sufficient. Okay. Now, if the diagonals are equal and the diagonals bisect each other at 90 degree, the only common possibility out here, which I can see, is a square. From statement 1, statement 2, I can see the only common is square. I can get my answer by combining both these statements. So I'll say my answer is option C. Is this perfectly clear, guys? I've been talking for a long time. Please let me know if this is perfectly clear. Let me bring up a poll. If you have any questions, please ask. But I hope you appreciate the point, the importance of learning these properties. I'm going back to the properties once again. Somebody's asking me to go back. So I'm going back here. So Priyanka, I've bought the properties. If you want to take a screenshot of this, please take screenshots. Make a printout of it. Keep it with you. Learn it. Your questions that you're going to get in the exam would be direct application of these. Okay, and I've tried to keep it in an order, in a progressive order, so it's easy to remember. Okay, I can see it's clear to everyone. So let me go to the next question. Here's the next question, guys. And I'm going to give you 2 minutes to solve this question. And here's the poll. Hey, Akshat, yes, I have a question whether the recording will be shared or not. Yes, Akshat, we'll share the recording. If you want, you can also, I think I've told, given this before, but I'm sharing it again. You can subscribe to our YouTube channel, Akshat. All the recordings are shared, uploaded on this channel, any webinar that we take. So we'll mail you, but if you want to look at it anytime that you want, you can just subscribe to this YouTube link or bookmark it, whatever you want to do, so that you can access these recordings. Okay. Nishant, we will share the PDF of this webinar, but we do that at the end. Okay, guys, another 30 seconds, then I'm going to end the poll. Once again, if you know the properties, these questions are really easy. You can solve these questions very, very quickly. Ten seconds, then I'm going to end the poll. Okay, I'm ending the poll now. Okay, it's an interesting result. 44% of you think that the answer should be 20%. Okay. 2, 3, 5. Okay. Those and about 20%, 27% of you think B, then it's progressively decreasing. Some of you are saying also C. But anyways, how did you find this question, guys? Was it difficult, easy? Okay, Tatva says tough one. Okay. What about the others? Did you find this difficult? There are two very big learnings in this question, by the way, especially for people who are getting it wrong. What about the others? Did you find this difficult? Okay, Nana says difficult, Vaishnavi tough, Nathan says easy, not so difficult, 2 by 3 divided by 2. Okay, Sakib says tough, Vaishnavi, okay, great. So I think most of you are saying it's tough, which is fine. I'm going to talk about certain properties in this question, which will make your life really, really easy if you want to solve the question. So, okay, so I know it's very difficult to draw the diagram, so I made sure that I have a big diagram in front of me so that I can work on it quickly. Let me start by reading the question properly first. In this, we have a figure, as you can see, and the ratio of the lengths is given. So PT to TQ has been given as 2:3. So let me do one thing. Let me just first of all, since the ratio is given, what I do is I write it like this. So I write it as 2x and 3x. Okay, so the ratio is given. You can work with 2 and 3 also. That's totally okay. Now, another thing that have been told to me is that the quadrilateral is a parallelogram. So that's a very good information. So I know opposite sides are parallel, they are equal, right? So as I told you, automatically all properties should start coming in your mind very quickly. You may or may not use it. That's a totally different thing, but it makes sense to draw and mark things in the diagram. Now, whatever the question is asking us to find out the area of triangle PTS. Okay, triangle PTS. The area of triangle PTS is what percent? Okay, so they're asking about a percent. What percent of the area of quadrilateral QRST? Okay, so what percent of? So I have to find PTS with respect to QRST times 100. So this is the percentage that I am looking for. Now, when I was focusing on QRST, I hope those of you who made a mistake, who did not read properly, especially people who marked the answer as A, I hope now you understand the mistake that you have made. Some of you did not read the last part properly. You just thought there's a quadrilateral. You may have taken the full parallelogram and found out the answer. That's the first learning that I want to give you is, guys, please don't take things for granted. Read it properly. What quadrilateral are they talking about? It's not always necessary that they'll ask you about the full parallelogram. Okay, that's number one learning. Now, how to solve such questions? Now, there are two properties which I want to talk about, which I think is very important to solve such questions. In fact, in GMAT, recently I've seen certain questions being asked on this. So I won't, I'll go to the next slide because I want to draw a few diagrams. So I'll go back to this, but first of all, let's talk about some properties. Okay. Now, there are two properties which I would want you to understand very properly. One is the area property, which when it comes to parallelogram and a triangle. Okay. And the other property is of a single of a normal triangle only, which of something like this. Okay. Now let's talk about this first, the second one, because that's slightly difficult to understand. The first one is easy. Now, a lot of times you'll see in the exam, you'll be given a triangle like this, and you'll be given the ratio. Like in this case, let's say the ratio is again 2:3, so 2x, 3x. Let me take it as 2x, 3x. The ratio is given, okay? They'll tell you BD by DC is 2:3, okay? And they'll ask you, what is the ratio of the area of triangle ABD by triangle ADC? Or maybe triangle ABD by triangle ABC? A very common kind of question and a very easy question, by the way. Let me tell you what is the trick behind solving this question. This is like a 10-second question. You don't need to do anything if you understand the property. Now notice, if you'll notice one thing, whenever you get a triangle of this form, okay, you'll notice that the base, the height that I have to drop for both the triangle ADC, okay, and triangle ABD, you'll drop the height from here. You'll be dropping it like this, something like this. Okay, let me name this as AF or something. Okay. Now this height AF is common for both the triangles. So when you're finding the area of ABD, you're going to write half. A base is BD, which is 2x, and the height is AF. And for ADC, you're going to write half. Okay, my pen is acting a bit weird. I don't know why. Half 3x times, and again, the height for ADC from A is going to be AF only. So notice this AF, this half, this X, everything gets cancelled out and you're just left with 2 and 3. So the ratio that you get is 2 is to 3. Now notice the similarity. The area that you're getting is same as the area of the base. And why is this property valid? Because the height is common. So in the exam, if you are given a question like this, where there are two base ratio is given, and you're dealing with a triangle, the first thing that you need to check very quickly is, does this have a common height or not? If it has a common height, as I can show you here, then you can directly say that the area is going to be the same as the base ratio that is given. So it's going to be 2 is to 3. Now, please tell me whether this is perfectly clear or not, because it's quite important. So I'm bringing up a yes and no poll. If this is perfectly clear, please mark yes. Easy property, it's all that is required is that you are able to apply it, okay, and be able to visualize it in the exam. Okay, I can see it's 100%, which is good. Now, coming to ABD and ADC, here also understand, where even if you take the whole triangle ABC, okay, nothing's gonna change. ABD is obviously the same. It's going to be 2x and AF. But if you look at ABC, it's going to be half. Now the base becomes the whole thing. So 5x. And the height is still the same because you're dropping from A on the triangle ABC. So this is still going to be AF. So notice AF gets cancelled out, X gets cancelled out, half gets cancelled out, and you're left with 2 by 5. So if they ask you small triangle by the big triangle, all you have to say is, okay, small triangle base is 2, the total is 5, so 2 by 5. So in the exam, we don't even write these stuff that I've shown you here. The only thing that you need to be able to visualize and understand is the height is going to be the same. If the height is same for both the triangles, whatever is the base ratio is the actual answer for you, for the area also. Okay, that's property number 1. Okay. Now, the same property that I've shown you here, and I'm assuming that you understood ABC also, so I'm not going to ask, I'm not bringing up a poll, but the same property can be applied here also. For example, if I, with slight difference, by the way, but it's the same thing, I'll show you. First of all, let me take a case like this. Let me take a case like this. So I'm drawing a triangle here, ABC, in a parallelogram, say DE. So this is a parallelogram DECB. It's a parallelogram, and I'm drawing a triangle inside it. Now, a special property of two parallel lines is, if you're not aware, let me just tell you, the perpendicular distance between two parallel lines is always the same. It's wherever you draw it, it's going to be the same. Okay, that's a very important property. If you do not know it, make a note of it. Now, here's an interesting thing here. Notice the height that you draw from A, and if this is touching here, the height is going to be the same. If you draw it from D to this, or from A or from E, does not matter. It's still going to be the same. So when you're finding out the area of the triangle, you're going to write half. The base is BC, and the height is A, say F, for example, once again. And for the area of the parallelogram, it is base BC times AF. So notice, if you have a triangle like this, between a parallelogram, the area of this triangle is half of the full parallelogram. It's half of it. Okay, I hope this part is clear. And I'm going to use these two properties to solve the question. So if you have any doubts, please ask in the chat box. If there are no doubt, let me bring up the poll again. Please mark yes if this is clear. Okay. If there's any doubt, please ask. If you're saying no, I don't have a problem, but you need to tell me what did you not understand. I'm using just two properties. One property is half base times height. Number two is obviously the area property of the triangle, half base times height. And the other one is the parallelogram property, which is base times height. Okay. Tatwa, when you say is the new bit, what do you mean by that? Are you talking about this one? If you're talking about this one, just understand this. See this. This is the base, BC. This is the height, AF. Okay. So area of triangle is half BC times AF. Okay. Same way for a parallelogram, I just showed you in the table that it is base times height. So this is the base BC, this is the height AF. So BC AF. So basically this is area of triangle ABC by parallelogram BDEC. So what I'm trying to show you is ABC by BDEC is half. That's all I'm trying to show you, nothing else. Okay, so I hope this is clear, Hitakshi. That's why I hope this is perfectly clear now. So keeping this property in mind, now let's look at this question. Okay, and there are a number of ways of doing it. Let me be very clear here. There are a lot of ways of doing it. I'm just showing you one of the ways of solving this question. So what you can do is you can think in this way that this is 2 and this is 3. Okay, it's a parallelogram. So this length has to be equal to the length, that is, since the opposite sides are equal. So 2x plus 3x is 5x. So you can say that this is 5x. Okay, I hope this part is clear. Because in a parallelogram, opposite sides are equal. So if this is 2x plus 3x, this whole thing is 5x. Then SR is also 5x. Okay, that's number one. Number two thing that you need to see is that the height that you drop. Let me drop a height. I hope I'll be able to draw a straight line as close as possible. Okay. Let me name this as S, what Z is there. So let's name the height as Z. So I'm naming the height as SZ. Now this height is going to be the same for this triangle SPT and for this quadrilateral. Now can anyone tell me what kind of a quadrilateral is QRST? Can anyone tell me what kind of a quadrilateral is QRST? I'll give you a small hint. Notice TQ, SR are parallel. Focus on SRQT, that quadrilateral. What kind of a quadrilateral is it? Anyone? Okay, Ashwin, Yashvi, you're correct. Tatva, notice it's not a parallelogram because notice it would have been a parallelogram if RQ and ST would have been parallel, but ST and RQ are not parallel. Notice these two are not parallel. This one and this one, they are not parallel. So it's a trapezium because only one pair of sides are parallel, this side and this side. So now that you've recognized it, notice how easy it is to solve the question. I'll simply write half. For a base, it is 2x for a triangle, PTS. The height is, as I told you, I've written it as SZ. So I'll write it as SZ. Okay. Divided by, for a trapezium, I told you the formula is half into sum of parallel sides, 5x plus 3x parallel sides, which is 8x, sum of parallel sides, into the perpendicular distance. And I told you between parallel lines, the perpendicular distance is always the same. So you'll write it as SZ. And since you're looking for a percentage, you'll multiply it by 100. So notice half getting cancelled out, SZ being cancelled out. You're left with 1 by 4 here times 100, which is 25%. So tell me, guys, was this difficult? If you know the property, if you know that property that between parallel sides, the perpendicular height is the same. If the perpendicular height is the same, then the base ratio plays a big role in finding out the answer. Do you think it's difficult? The moment we recognize that this is the property that we're going to use, you can type in your response in the chat box. I hope by now it's perfectly clear. And the purpose of the first two questions which I gave you was this only. First one, as you saw, just a direct application of the property. You know the property, you know what quadrilateral you're dealing with. Second question, again, property of a perpendicular and base ratio. Very important property. If you know it, a lot of triangle questions, a lot of quadrilateral questions can be solved very easily. That's why, yes, that's the condition. That's the first thing which I told while starting the session. If we know the property, if you don't know, then obviously the discussion would be futile. But if you know the property, the only thing that you need to keep in mind is to be able to recall these. So that's why it has to be second to nature for you. You should be able to see a diagram like this, a parallelogram. You see a parallelogram, you see a triangle, that should be a trigger for you. And especially if it's dealing with an area, you should, that's a trigger that, hey, I'm dealing with bases. Height is going to be the same. That is how I remember it. and how I keep on thinking how to approach a question. Okay, so I think it's clear to everyone. So let's move on to the third question. Here's the third one. And now we are slowly moving from quadrilaterals to polygons. So let me bring up the poll. Riddhi, we can do that. You can find out QRST also, and that's a disclaimer I gave that this is one of the ways of doing it. You could have used that thing also. You could have found the area of the parallelogram and then subtracted it. That would have also worked. It will give you the same answer, Riddhi. Okay, you can see questions from Ashwin and Jeet. They are asking the same question. We have some questions on coordinate geometry, but 2 of them only. So if this session is encapsulating everything. So I'm moving from quadrilateral to polygons to circles, and then finally to coordinate. Okay, so I hope that answers your query. Guys, another 30 seconds. Again, a very interesting, a very common mistake made by people in these kind of questions. Ten seconds, then I'm going to end the poll. Okay, I'm ending the poll now. Okay, so about 40% of you think that the answer should be A, and about 35% of you think that the answer should be C, and I have about 13% who think should be B. Okay, first of all, I have a few questions for you. Like, if you notice that in the question stem, it's given that all the sides of a polygon are equal. Now, tell me, if I know all the sides of a polygon are equal, what is the first inference that I can make? Anyone? All the sides of a polygon are equal. What inference can we make? Or can we make any inference? Either way, you can let me know. Okay, Sugandha says regular polygon. Elena says a hexagon. All internal length equal, could be a square, regular polygon. Okay, so this was a trick question, by the way. Okay, we cannot make any inference. All we can say is that we are dealing with a polygon. A polygon, please let me be very clear, a polygon where sides are equal, nothing else. Now, a lot of you will end up thinking that it's a regular polygon. Okay, those of you who think that after reading all sides are equal, we can infer all angles are equal, you're making a mistake, a very common mistake. It's totally okay for making it. Now, I've told you it's a mistake. Okay, so tell me, can you think, so you understand what a regular polygon is, by the way, since you're responding to it. So a regular polygon is obviously a polygon, and I have a slide on this, so let me go there first. A regular polygon basically is a polygon where all sides are equal and obviously all angles are equal. Okay. But tell me, if I know all sides are equal, as I told you, we cannot say it's a regular polygon. Can you give me an example where all sides are equal and it is still not a regular polygon? Any example, anyone? All sides equal, still not a regular polygon. And I discussed this, by the way. I did discuss it. Okay, Jeet says a parallelogram with equal sides but not all angles equal. What is it known as, Jeet? Yashavi says star. Rhombus. Yeah, that's a very simple answer, right? It's a rhombus. I just told you rhombus is a special polygon. It's a special parallelogram where all sides are equal, but all angles are not equal, right? So rhombus is an example that you need to keep in mind so that you don't make this mistake again. Okay. Now, can you think of a polygon where all angles are equal, but it is still not a regular polygon? All angles equal, but it is still not a regular polygon. Can anyone think of an example? This one is an easy one. All angles equal, still not a regular polygon. Yes, Shivam is correct. It's a rectangle, right? Where all angles are equal, but it's still not a regular polygon. So please, guys, make a note for yourself that you can infer that it is a regular polygon only and only if you know all sides and all angles are equal. Okay, triangle being an exception, by the way. In a triangle, if you know all sides are equal, then obviously you're dealing with an equilateral triangle. All angles will be equal. But if when you start above from triangle, more than 3 sides, 4, 5, 6, 7, whatever, in those cases, okay, you need to know that all sides and all angles are equal. Both should be mentioned, or they should explicitly state that you're dealing with a regular polygon. Only then infer that all sides all are equal. Just knowing all sides are equal is not enough. Just knowing all angles are equal is not enough. Okay, that's a very important learning. So I hope you have made a note of it. Okay, so here are some examples. You already know this. I'm not getting into it. But the more important thing is that you should know these two formulas. So if you are not aware of the formula, how to find each interior angle and each exterior. Okay, there's a typo here, small one. Let me correct it. It is exterior. Each interior and each exterior angle, if you don't know, then you should make a note of these two formulas. So if you know it's a regular polygon, once you know you're dealing with a regular polygon, you can use these two formula, n minus 2 times 180 by n, to find out each interior angle, the value of each interior angle. Okay. And if you want to find the value of each exterior angle, then you use 360 by n. Okay. So I hope this part is clear, because we are going to use just one of the formulas to solve this question. Now, this is also a very easy question. All you had to do are easy if you know the properties, by the way. All the sides are equal. We cannot make any inference. We need to find how many sides does it have. Okay, we need to find out the value of n, the number of sides. Now, the first statement is has an external angle. So they're talking about just one external angle. One external angle is 60 degrees. Now, this is not enough for us to answer the question, because by reading this, we don't know whether this is a regular polygon or not. We don't know this. Since we don't know this, we cannot use the formula of each exterior angle. The formula that I showed you now for each exterior angle, which is 360 by n, I cannot use this because I don't know what I'm dealing with. So this statement is not sufficient. So those of you who marked the answer as A, which majority of you did, you assumed it to be a regular polygon. I hope you don't make that mistake again. Okay. Second statement in itself. Now, some of you marked the answer as B. You have to think this is not enough. All interior angles of P are equal. Okay. This is only telling you after combining the information given in the statement that all sides equal, all internal angles equal. So using just the statement 2, you can infer you're dealing with a regular polygon. Okay, so I'm writing it as short regular polygon. Okay, but you don't have any other information to find it. So statement 2 just tells you regular polygon, that's all. So you cannot do anything. So obviously statement 2 is also not sufficient. See how quickly you can make these inferences very quickly if you know the properties. If you combine, you know you're dealing with a regular polygon. You know if one of the external angle is 60, all of them is going to be 60. So now you can use this formula. You can say each external angle is 60, 360 by n, and then you find out the value of n as 6. So the correct answer in this case is going to be option C. I hope this is perfectly clear, guys. If there are any doubts, please ask. If not, let me know in this poll. If this is perfectly clear, please mark yes. I hope you learned a lot from this question, the properties, the formulas, and I hope you do not repeat these mistakes again. Okay, so we have discussed properties of quadrilateral. We have understood a bit about polygons also, how to deal with angles, and these are all common kind of questions. And let's now look at another common property of a polygon, something which comes quite frequently, that is hexagons. Okay, so here's a question on hexagons. Try it out and then we'll discuss. I can still see about 5% if you're saying that you haven't understood the previous question. I would request you to please ask in the chat box if there's anything that I can help you with. Okay, for those of you, if this is perfectly clear, I would request you to start the next question. Another 30 seconds. The good thing is the accuracy for this question is pretty good so far. I'm happy about it. Okay, 10 seconds and I'm going to end the poll. Okay, I'm ending the poll now. So good thing is that about 74% of you marked the answer as B, which if I remember correctly is the correct answer. Obviously, we'll discuss it. I have a few C's, D's, and E's. So I'm going to discuss what could be the probable reason for you making a mistake in this question. Okay, so first of all, when you're dealing with a hexagon, in most of the cases, the questions that come on hexagon are based on area or angle. Okay, now that you know the formula of total internal angle and external angle, you can use that to find out the value of each internal angle. So this is just a brief theory which I wanted to give you so that whenever you're dealing with regular hexagon, you know how to solve it very quickly. Now in a regular hexagon, each internal angle is 120, first of all. It's best that you remember this. Obviously, you can use this formula if you want to, the one that I discussed earlier, n minus 2 times 180 by n. You can use this to find out the value, but it is better that you remember it. Okay. Now, if you join all the lines, okay, all the diagonals like this, what happens is that the angles split equally into 60, 60, 60, 60. Now notice a very interesting thing here. What you're getting here is basically 6 equilateral triangles. And notice very carefully, because if you have these two angles as 60, then that means even this is 60, right? If these two are 60, then this is 60, this is 60, this is 60. All these are 60. So basically, when you join all the diagonals, you get 6 equilateral triangles. Okay, that is something which you should definitely remember and not infer it during derive it during the exam. Just learn it. So if you know the length of one side A, say for example, you know that all the lengths inside also this length, because it's an equilateral triangle, these lengths are also going to be A. Let me remove the 60 now, because I think this part is clear that they are equilateral. So all these lengths are going to be A because we have an equilateral triangle. Okay, and if in the exam, if you're ever asked, find out the area of an equilateral triangle or whatever, or say for example, you'll notice sometimes they ask you the area of this region also, this region. You'll see a lot of questions like this. So you know you're dealing with basically 3 equilateral triangles, nothing else. So if you know the length of one side, you can just multiply it by 3. You can do 3 times root 3 by 4 into a square, and you can get the area of this part. Okay, so this is really powerful, really important, and can solve. You can solve hexagon area-related questions very quickly using this property. As far as the total area is concerned, obviously you can use this. Is this part clear? Again, I'm going through these theory parts because I just want to make sure that you are totally comfortable with this. Kindly mark yes if this is clear. Okay. So long story short, if you know it's a regular hexagon, you get 6 equilateral triangles. And also notice the length of the diagonal, if you notice here, is basically AA, 2 times A, right? That's so if you're given the length of one diagonal, you can say the length of the diagonal is basically 2A. And this is what I'm going to use now. Now in this question, notice everything is the same. You have a regular hexagon. This is the center point. You know that they are divided into 6 parts. So you have 6 equilateral triangles here. Okay. AD is 8. Notice AD is what? AD, as I told you, is the diagonal, which is A plus A, 2A. So this is 2A. You can say 2A is equal to 8, or the length of each side is 4. Now, those of you who did not do this, who used 8, may have ended up marking the answer as maybe 64 or something like that, or 32. There's a high chance. But that's the first thing that you need to do. Find A. Second thing which you need to notice is that they're asking you about they're asking about 4 triangles, not all 6 of them. So those of you who ended up doing maybe this, A square, which is 4 times 4, if I write it like this, you may have ended up marking the answer as C. Some of you did, about 9% of you did it. This could be one of the reasons you did not read proper, you did not notice properly that you're just looking for the shaded region. All you had to do was, there are 4 triangles, so you should have said 4 triangles. So 4 equilateral triangles. Area of equilateral triangle is this. So my answer is 16 root 3. Done. So the correct answer in this case is option B, which most of you marked as the correct answer, which is pretty good. But see, notice that these questions, these questions are 650 level questions, by the way. Okay, some of you are not able to solve it because you just don't know the property. But you can see these are all questions that can be solved under 30 seconds. Any doubts, any questions, please ask. So I have a question. Sum of internal angle is n minus 2. Yes, that's the formula, is n minus 2 times 180. That's correct. Any other question, guys? If not, then I'll move on to the next question. I think we are done with polygons. I'll move to circles now. Okay, I don't see any questions on the chat box, so that's great. Let's move on to the next question. Here's the next one. Another, again, a very interesting question. And let me bring up the poll. Okay, guys, another 30 seconds, then I'm going to end the poll. Okay, I'm going to end the poll now. So those of you who haven't put in your responses, please do so quickly. Okay, I'm ending the poll. Okay, I have an interesting response. Okay, I have a few questions regarding the last question. In the last question, how did we know that the height was radical root 3? So Mark, the formula for an equilateral triangle is root 3 by 4 into a square. Okay, so since we had inferred that it's an equilateral triangle, so that is why we use that formula to find the area. Okay, but the height is basically root 3 by 2 times a. If you want to know the height for an equilateral triangle, that's written like this. It's there in the video lesson of triangles too, by the way, if you want to look at it. I've discussed how to find the height and the area, Mark. Okay. Now, coming to this question, I think, guys, if I remember correctly, none of you have got the answer correct. Frankly speaking, that is what it looks like. So I have a split between B and C. B, as far as I remember, is definitely wrong. I don't think even C is the answer. So what property were you using to solve the question before I start discussing it? Can anyone tell me what did you use to solve this? What property did you use? In general, what did you do to solve this question? Okay, you thought about, so we are going to use angle by 360, Mark. That's important. We have to use it. That's at least if you're able to think in that direction, that's good. So we have to use, because it's talking about the perimeter. Okay, since t is given 100 by 360 per, okay. So I've closed the poll now, so that is why you're not able to use the poll at this point of time. Deepshubra, you, for the next question, when I open the poll, you can use it. Okay, I can see join TO, TQ is equilateral. Okay, that's a bit complicated. We shouldn't do that. Alma says circumference QTS plus QOS is equal to 180 degree. Okay, sort of the property that you have used. Finally, somebody says what I'm looking for, the answer that I'm looking for. So 100 degree subtends twice angle at the center. That's the thing that you need to use. Okay. So the property that we are going to use is this one, that, and again, let me discuss it. So basically angle SOQ. So Gandhi, you're correct, angle SOQ, but which angle SOQ is important? Okay, so that is where people make a mistake, Sugandha. So that's why I wanted to discuss this question. So in circles, if you're dealing with angles, so let me tell you, as I told you, I'll talk about approaches when you're solving a geometry question. So whenever you see a circle question when you're dealing with angles, okay, some of the things that you need to keep in mind is the angle property of theta to theta, which I'm going to talk now. You should be able to recall that somebody mentioned mentioned that the diameter subtends an angle of 90 degrees on the circumference. These are properties that you need to think, recall, and apply it. Now let's talk about theta and 2 theta first. So what this property says is, let's say uh, you draw a line like this from 2 points, okay? And say this angle on the circumference, if it's subtends an angle of x, say for example, from the same 2 points, when I say same 2 points, the 2 points which I mean are these two, okay? This point and this point on the circumference. If you, from the same 2 points, if you join and take it to the center, then the angle that is formed at the center is 2x. Okay, so from these 2 points, let me name it as AB, so it's easy to talk about. From AB, if you subtend on the circumference as, say, let me use a D here. If the angle ADB is x, then on the center it will be 2x. And this is something which is easy, most of you understand. But the mistake where most of you make is when you have, say, an angle like this. Okay, if this is x, and again, notice that I'm using the same 2 points. Okay, say, let me use A and B here also. This is, say, point A. This is, say, point B. And let's again name this as T. Okay, so when I'm trying to draw it on the center, okay, a lot of people make the mistake and say, hey, this is the angle. This is 2x. This is wrong. Okay, the angle that you need to take is this one. So think of it this way. This is the way sometimes I remember is that if I have an angle x here, I will discard this angle and I'll go to the next one. Or you can say that both the angles need to face the same side. So this angle is facing this side. This angle needs to face this side. So this. There are two ways. Number one, you remember it like this, or you can remember it like this, that you take this angle, the other angle is this one, after that you discard it and you take the next one. Up to you, whichever you want to use, but this is how you need to keep in mind. That especially for this one, you won't make a mistake in this one, I'm sure of. This is the place where there's a chance of you making a mistake. So keep in mind, if this is x, it's facing this way. You cannot this one because it's facing up. You're not going to take this one. You're going to take that's going to be on the downside. So this has to be 2x. Okay, is this part clear? Let me reset the poll and let me bring up a yes or no poll. Please mark yes if this is perfectly clear. Okay, great. I can see it's clear to everyone, which is good. Okay. So in this question also, I'm going to use the same property. And what I'm going to do is I'm going to say if this is 100, notice this is 100, and you're subtending it from Q and S, okay? You're subtending from this point to this point. So if this is 100, then this whole angle that you have here is going to be 200. Okay, I'll try to draw it. Drawing a circle is frankly slightly difficult for me, but I'll try my best. So think of it in this way. Okay, the center is already shifted, but I hope you will ignore my messy drawing. I'm not really good with this with the pen so far. Okay, so if this is 100, this whole thing is 200. Okay. Now, second thing is I want what do I need to find out? And here is something which I wanted to talk about is you should read what they are talking about in the question. If there's a difference between when I say perimeter, okay, perimeter of sector SRPQ, and when I say length of, let me just use this, okay, when I say length of arc SPRQ. When I just talk about length of an arc, okay, just the length of an arc, and let me use a different color, by the way, if that would be better. Let me use a red color now. When I talk about length of the arc, I talk about this part. Okay, just this portion. Okay, this one. And that is, guys, as you said, the formula is correct. Theta by 360 times 2 pi r. That's the formula to find out the length. Okay. When I talk about sector, when I talk about perimeter, by the way, okay, when I say the word perimeter of a sector, and I hope you understand sector. Sector is like this whole thing. This whole portion is known as a sector. This whole thing is a sector. That means you're looking for this, and this is you're looking for this length and this length also. So you need to add up these two lengths also. Okay, this length plus this length. So that's the difference between just the perimeter, just the length of an arc, where this is theta by 360 plus 2 pi r. And when you're talking about the perimeter of a sector, that means the whole sector is this, the whole thing. Then you have to take the account the length of the arc plus the two diameters, or the two radiuses also. So 2 times r. Is this clear or not? Because if this is clear, half the job is done. I just need to plug in the value of r and get the answer. Please mark yes if this is perfectly clear. So two major learnings from this question. Number one learning is about theta and 2 theta. Make sure that uh, whenever you take an angle, you leave this one, you move on to the other one, that is your angle. Okay, the one that I've shown you here. These two scenarios you should remember properly. Second is you should be able to understand the difference between the perimeter and the length. If they're talking about just the length of the arc, use just theta by 360 times 2 pi r. If they're talking about the perimeter, add up the two radiuses also. Okay, or whatever length that is there encapsulating it. Okay, now theta is 200, so I'll put the value of 200 here, and I am removing this diagram for now. Okay, because I need space to work on this. So I have 200 by 360 times 2 pi. Now radius. Now RS is 36. What is RS? RS is the diameter. Okay, the diameter. So the radius in this case is going to be 18, half of it. So I have to make sure that I don't make this mistake. Now 2R is basically the diameter only, so I can write 36. So the moment I write 36, I know my answer is not going to be this. Now, think in this way also. In the exam, if I'm solving this question and I see a perimeter, I know I have to add two radiuses. So I can directly discard all these three cases. I'll know at least these three won't be my answer because I need my radius. So my answer has to be either D or E. Okay. And from here, if you notice, if I cancel this out, I'll get 20, right? And this is going to be 10. So this is 20 pi plus 36. So the answer in this case is going to be option E. So I hope this is clear. If you have any doubts, ask. Again, I'll let me look at the chat box. I can see there are a few things, but if this is finally clear, you can mark yes, and I'll look at a few things. Ashwin's asking, is this a 700 level question? Yes, close to 700, I would say, because of the two of this theta property. Most of you get it wrong, but apart from that, it's easy. I would still put it between 650 to 700, depending whether you know the property or not. Okay, Pooja is asking, why have you added 2R? Pooja, as I told you, we're looking for the perimeter, right? When you're looking for the perimeter, you need to take the length of the arc plus the two lengths that is encapsulating it. So notice I have to take this portion, this length, plus this length, because it's talking about the perimeter. That's the difference that I was trying to make you understand. If it is just length, if the question just asks about length, you'll do this. If they ask about perimeter, you'll add 2R. Why 2R? Because you need to add QO plus OS, and they are radiuses. This is R, this is R. So I hope this answers your query. Pratik is asking, is it a 700 plus or not? Guys, why are you so hell-bent on knowing it's 700 or not? It's close to 700, but I won't say it's 700 plus. So there's a category of 750 also. It's not, it doesn't fall in that category, Pratik. Okay, any other questions? Okay, I don't see any. So let's move on to the next question, guys. Okay, here's the next one. Hey Isha, I just noticed I missed your response. Yeah, you can do that, what you have mentioned. If you are approximating it, then you can do this methodology also. Thankfully, there's just one option which is greater than what you did, but there is a possibility that in the exam, if there's something else, then that approximation might not work. Okay. Guys, another 30 seconds, then I'll end the poll. Ten seconds. Okay, I'm ending the poll now. I have a very interesting result, by the way. Okay, let me end it. Wow, look at this. 35% E, 30% C, 20% B, and about 15% if you mark the answer as D. So this clearly shows that obviously there's a lot of confusion behind this question. And this is a slightly difficult one, by the way. But the reason behind choosing this question, where you're talking about semicircles, some lines on the semicircles, this is a typical question which comes into the advanced section of the topics that I was talking about, where you're dealing with circles, you're dealing with triangles, and in questions like these, it becomes difficult for most of the students. What I've seen is they don't know what to apply or how to approach it. Now, while you were doing it, were you falling under this category? How many of you felt, hey, I don't know what to do? There's so many things. What should I do with it? How many of you were in this category? You can just type in the chat box, even your thoughts about this question, whether you felt it difficult, you were clueless, what happened with this one? Okay. Sakib says me, Pinaki clueless, Isha me clueless. Okay, puzzled. It's tough to where to start. Okay, clueless. Okay, okay, guys. This was the question which I was doing a few days back with one of my private tutoring students, and he was also facing the same problem. He didn't know exactly what to do and how to start. Okay, and that got me thinking that how do I approach such a question? What do I basically do in this question? Well, the first and the foremost thing which I basically do whenever I get a question, I think I told you before in a few questions also, is that I mark everything down in the diagram first. That's the first thing. I don't know whether I'll use it or not use it. That's a different story altogether. But I'll spend 10 to 15 seconds just to make sure that I jot down everything. Like for example, in this question, I know from the point O, I can just mark all the radiuses which are equal, right? So I'll mark OP, OQ, OR, and whatever the tiny bit is in the exam. If you may get confused, then you may even write it as X and then say OX. These four are basically radiuses. That's the first thing I'll do. Okay. Then after that, if you look at the diagram, you can see there are triangles in it, right? Now, when there are triangles, you need to think, and when the sides are equal, you need to start thinking in terms of special triangles, and that is something which I usually teach in triangles too in our video lessons, where I tell you that in the exam, and especially in GMAT, thankfully, you have to worry about only these four kind of triangles, special triangles. So if you see lengths are equal, the first thing that you should do is mark them down. Okay, so the moment I see these two lengths are equal, that this and this are equal, if this is 48, I'll mark this as 48. I'll do that. Okay, In fact, if you want, you can use variables also to mark the remaining sides, remaining angles, sorry. So in this triangle ROQ, you know OQ and OR are equal, so the angles have to be equal. Okay. And since you're dealing with triangles and since you're dealing with angles, okay, the next thing that you need to do is start thinking, okay, I have angles. I'm trying to find out what is the value of the angle. So what are the angle properties do I know? Okay, so you start thinking in terms of a triangle. You can say that in a triangle, I know external angle properties, I know internal angle properties, I know straight line angle properties. These are three properties that are there. So let me try and see whether I can apply them in some way or not. Okay. Now, the only difference between your and my approach is this, that I am sequentially moving towards the question. First, what am I doing is I'm marking everything. That is something which I do universally for all questions. Okay. Number two is I look at the type of question that I'm dealing with. So if it is circles and angles, I think in terms of theta to theta, okay, 90-degree, these kind of things. If it's a triangle with angles, okay, I start thinking in terms of external angle, internal angle, and straight line angle, because these are the three that are frequently tested in the exam. If I see sides are equal, I start thinking in terms of special triangles. And believe me, out of these, something will click. It has to. There's no other way it will. There's no way it won't. It will not. Okay. So it is very important that you start thinking in these directions. Okay. I'll show you how I'll use this to get the answer. Okay. In this case also. So I'll start off fresh. I'll read the question one by one and I'll mark everything that is given in the question. Okay. So I know the lengths are equal. So obviously I'll do this part. I can mark this small part also if I want to. And I'll mark this as 48. Okay. Up to you. You can either just draw something like this and say they are equal if you want to, or you can mark them as X. I'll leave that totally up to you depending on personal preference. Okay. Anything else that is given? If you want, you can mark these also. Okay, you cannot mark this also. Some of you might make the mistake of marking it because these two are equal, so I cannot do anything else. I'll pause here. And I'll name this as something else because I've already used X. So let me mark this as Z. Okay. So all this have been used. What do I need to find out? I need to find out angle ROS. So what I'll do is I will just highlight it very properly in the diagram that, hey, this is what is my ultimate goal is. I need to find out this. Okay. Now, no other information is given in the question, which so I'll now move on to the statement and see whether I can get my answer or not. Okay. So I'll move to the first statement. I'll see it's given that SR is equal to OQ. Okay. SR, this length, is equal to OQ. So notice this is the radius, right? These are all radiuses. So if you get confused, even you can mark this. Okay. These are radiuses. Okay. So what you can do is now notice. I don't want to clutter it. Notice. Look at this length. Let me remove this R because this might confuse you. Look at triangle ROS. Now you might say, hey, why am I looking at this? I'll say the reason is very logical here because we are dealing with angle ROS. It makes sense to look at that triangle first. And notice in this case also you have two sides equal. So what I'll do is I'll mark this also as something. I'll say this is Y and this is Y. Okay. And now you might say, hey, why, so what? I cannot do anything else, right? But then I'll say, okay, but did you think in terms of total internal angles? Did you think in terms of total external angle? Did you try and see if I'm dealing with ROS, is there any external or internal angle property that I can use to get my answer? Okay. Now in this case, notice something interesting here is that this angle, the one that I marked X, this is basically the external angle of ROS. And let me draw it separately so that you'll be able to visualize it. Notice this is Y, and this is X. This is basically the external angle of triangle ROS. Is this perfectly clear or not? Let me bring up the poll. Is this clear? Please mark yes if this is clear. Ashwin is asking how is angle PQO? Because it's the radius, Ashwin. I just told you, right? It's the radius. OP, OQ, these are all the radius, Ashwin. So that's why it's 4. Hitakshi is saying applied properties but couldn't find a link. That's okay. I'm just trying to show you how you can think in these directions. I can still see a few nodes. If there's something which is not clear, please ask. The external angle property is basically, if those of you don't know, is external angle is basically sum of opposite two internal angles. If you don't know this, I would highly suggest that you go through the triangles video lesson so that this is perfectly clear to all of you. Okay. Any other questions, guys? Please ask in the chat box. Those of you are saying no. So what can I say here? External angle x is sum of two internal angles. So sum of two internal opposite to internal angle is y. So x is equal to 2y. See, notice I found a relation between x and y. Now what I can do is I can replace this by 2y and this by 2y. Did you note it? I just used the external properties so far. Okay. Now I would say, okay, now you would say, okay, y, 2y. So what is the use of this? That's a good question. Look at triangle. Look at the big triangle QSP. Look at the big triangle QSP. Notice the sum of internal angles of QSP. 48 plus 48 plus 2y plus y. The sum of this will be equal to 180 degree because it is sum of internal angles. And again, those of you who are not able to visualize it, I'm drawing it separately for you. QSP. S is y. Q is total 48 plus 2y. And this is 48. Now I don't need to solve it because I know I'll be able to find out the value of y. So this statement turns out to be sufficient. If you have any doubts, please ask. Ashwin is saying, sorry, I didn't get you again, or have you removed it? Okay, can you name the points on your triangle? Okay, Mark, I'm repeating it again very quickly. So guys, those of you who did not understand, I'm just marking it again. Notice that this is the radius. This is the radius. So in triangle QOP is an isosceles triangle. So if this is 48, this has to be 48. Opposite two angles so you have to be able to visualize a triangle even if it is inverted. And I've used up the space. I'll come back to this slide, don't worry, but I just want to show you very quickly. If you have something like this, if this is 48, then this will also be 48. Okay, so I hope this is clear how I got 48. Okay, second thing which I did was this was x, this was x. Okay, then I took triangle RSO. So I'm writing it here. Notice RSO. This is y, this is y. Already you can see in the diagram. Y. And this is x. I told you external angle is sum of two opposite angles. External angle is sum of two opposite internal angles. So x is equal to 2y. That's a property which I figured out, which I used to figure out the relation between x and y. I made this 2y. I made this 2y. And then I looked at the big triangle QSP. So I'm marking this in bold here. I've drawn it separately also here. I hope you can see I've used this angle y, 48, and this full angle. And the sum of these three angles I've shown you here is equal to 180 degree. You can use this linear equation to solve for the value of y. Any doubts at all, please ask. Nitin's asking why x could not 48 since. Okay, good question, Nitin, but understand it doesn't mean, for example, let me take here, or let me use this part. These two are 48. And if I draw something, another line here, and make a triangle with these two length equal, that doesn't make these two also 48. They could be some other angle also. Nobody is stopping from that. Please understand, I could have this as 60, just a random example, 60, 60, 60. That's not a problem. Okay, and this could be 48, very well be 48. Okay, just because all four lengths are equal doesn't make the angles also need to be equal. I hope that answers your query, Nathan. Okay, I is asking, could we use half? No. So here you cannot, you need to also understand that you cannot use such properties. You have to use the property of theta to theta. You should have 2 points from the circumference on the circumference and on the circles. You don't have that in this question. Okay. Just to make it very clear, there are other ways also of doing it. I have just used one of it. You can use external property again to find out the answer. I did not go into it. Okay. Somebody's asking how is QSP? I'm not saying angle QSP. I'm saying triangle QSP. This triangle QSP, in triangle QSP, sum of internal angle, the sum of all three angles which I've written here, sum of internal angles is always 180 degrees. So if you sum up all the angles, you'll get 180 degree. Okay, Shaksham, I hope that answers your query. So I hope this is clear. If there's still if still not clear, I'll be sharing the video obviously recording with you. You can go through it once again, guys. Okay. If there are any minor doubts, please feel free to put it in the chat box. I'll explain it to you. Else, I'm moving on to the next statement. Okay. So statement 1 was sufficient. So obviously my answer has to be either A or D. So let's look at this statement. Now again, once again, I'll very quickly mark the points. I'll write this as X, this as X. I'll very quickly redraw the diagram. This is the information that I already had from the question stem. Now they are telling me RSO is 28. Okay, RSO is 28. Okay, RSO is 28. What can we do with this? Can anyone tell me? Can we use RSO is equal to 28 to find out ROS? I need this. How can I find out this? Anyone? Now that you have or whether we can find it or not, both ways. If you think that we cannot find it, that's fine. But if you think we can find it, can you think of what property to use? I need this. I have 28. What should I do with this? If you've understood the previous statement, you should be able to tell me what we can do in this. Okay, Jeet says no way. Nitin says use bigger triangle. QSP, very good, guys. You have to use the bigger triangle. Very good. So again, what you can do is you can go to the bigger triangle QSP once again, and you can say 28, this angle, plus 48, plus this full angle, 48 plus X, is equal to 180 degree. Okay, from here find X. I'm not finding it, I'm just writing it out. I will find X easily. It's a data sufficiency question, so I don't need to solve it. Okay, but how is this X useful? Again, think about it. In statement 1, we realized that this X is an external angle, right? External angle of these two angles. So we can say X is equal to 28 plus angle ROS. So we can find X from this equation, and we can plug it here and find ROS. So even this statement is sufficient. Is this clear? Yes, Riddhi. So all of you are able to see this, understand this correctly, right? This is, so see guys, understand this, that those of you are saying can't find, you're still not looking at the whole picture. See, look at the diagram. What am I doing? And understand this, and GMAT questions are almost using the same property, thankfully. So all you need to do is think in this way. Think of external angle properties, actually mark it. If you're not able to do it the way I was showing it to you, if you have confusion, separate the triangles if you have to. Like when I was doing 48, 48, I separated it to look at it, right? When you're looking at ROS, think about ROS only, and think, okay, internal, I cannot do anything, but is there any external that is present or not? The moment you ask yourself, you'll be able to see an external angle. The thing is that you need to ask. If you don't ask, you will never be able to see it, guys. Okay. Yeah, these are tough questions. In the exam, I'm telling you, sometimes you might feel, it might seem a bit tricky, but I'm telling you, use the methodical step. Mark everything. Think what kind of triangle are you given, or a circle are you given. Recall those properties one by one. Something or the other will definitely work out. For example, in this case, a lot of you might even think in this way, okay, 48 is 96. So this has to be 84. Okay, you could have thought in this way, okay, this is 96. Okay, then you could have looked at the big triangle x plus 28 plus 96 is equal to, so I'm just showing you, I'm just telling you that if you start thinking somewhere or the other, you'll get the answer. Even this is another way of getting the value of x. This is another way. Now, why was I able to think of another way? Because I'm very clear about the angle that I'm looking at. I know that this is 48, this is 84, this has to be 96, because I'm using straight line angle property now to get 84 plus 96 is 180. Okay, so I think I've emphasized enough on the importance of following it sequentially. Okay, Sumit, even if you take 2.5 minutes, say even 3 minutes to solve the question, it's worth it because it's a difficult question. So I'm okay even if you're spending 3 minutes in this question, Sumit. So it depends. So Sumit is asking how much time should we spend on certain questions and should we move forward? So guys, that's a call that you have to take while solving the question, okay? So for example, while solving the question, if you have a feeling that you have no clue, even after sequentially applying external, internal, straight line angle property, nothing is working out for you, then it makes sense to move forward. But that is a call you should be able to take after 1.5 minutes because it will take 30 seconds to mark everything, another 1 minute to think about it, whether you know anything or not. If not, then move on. But 3 minutes, if you think that you're close and you may get the answer by spending 2.5, 3 minutes, not a problem. Spending 3 minutes in it. Okay. Okay, guys. So I'm moving on to the next question. I think this is perfectly clear. So here's the 7th question on circle, which is based on visualization and simplification. This is something which I expect most of you should be able to do it. It's not that difficult. Another 30 seconds, guys. 10 seconds, and I'm going to end the poll. The good thing is that most of you are getting this one correct, which is good. Okay, I'm going to end the poll now. Okay, so 65% of you think the answer should be D, which I think, if I remember correctly, is D only. But I have a few of you who marked the answer as A, B. In fact, 8% of you marked the answer as C also. So let's go through it very quickly. This is not very difficult, frankly. Now, in this question, if you notice, you have been given a big circle, two small circles. If you have to summarize it, I'll put it this way, that you have a big circle with diameter US, and the center is O, as shown here. Okay, and then you have two small circles with centers P and Q. That is all that we have been given, nothing else. And obviously they have been told that these points lie on the line, which is totally fine. What we need to do is find out the area of the shaded region. Now, to find out the area of the shaded region, obviously, we can see what we need to do is we need to find area of bigger triangle. Okay, area, let me write it this way, not triangle, circle, really, sorry. Area of big circle minus, and these two circles are the same, identical in nature. They have already told us that. So 2 times the area of the small circle. right? Area of the big circle can be written as pi capital R square minus 2 times pi. If you want, you can write 2 small r square. So to find out the answer before going into the statements, it's very clear, it's pretty evident that we need the radiuses. If you don't know the radiuses, we will not get the answer. Okay. Now in the diagram, let's go to the statement if you want to, and if you want, you can mark these small things if you want to. This is small r, this is small r, this is small r, and I don't know how much this is, but that's fine. Okay, this could be say x and x, something like this. If you want to draw it, you can draw it. Now let's look at what is given to us. We are told that UP is 5. Okay, good thing. They're telling me UP is 5. So I know this is 5. So this also has to be 5. This also has to be 5. This also has to be 5. OR is 2. Okay, so if OR is 2, obviously, since see, O is the center, okay, this is the center point. So this whole part is the radius. So this is 12. So obviously this also needs to be 12, right? So if this is to this, if those of you are wondering why I wrote x and x for them, just to make tell you why I wrote it x, because they have to be equal. So even this will be 2. Now notice I have everything. I have small r is 5, capital R is 12. I can plug it in and get my answer. So statement 1 is definitely sufficient. If you have any questions here, please ask. If this is perfectly clear, mark yes. If this is clear, please mark yes. Ashwin, you're correct. If the word identical would not have been given, then it would have been difficult to find the answer. Everything depended on the fact that it has to be identical. Okay. So I can see that this is perfectly clear to all of you. So let's go to the second statement, and I'm doing it. Okay, let me do it in the next slide. Wait, yeah. Let's do it here. In the second statement, we are given TQ is 9. TQ. Okay, this whole thing is 9. Okay. SP is 19. Okay. SP is 19. Okay. Now notice, if you look at carefully, this part till here, this is 9, right? So, and I know the whole thing is 19. So I can say the remaining part, this part from here to here, and this part from here to here has to be 10, right? Because from here to here, this is 9. Now, this two are basically the radiuses, right? This is R, this is R, radius. So I can say this 10 that I have here can be equally split into 5 and 5. So this has to be 5. This has to be 5. I know this is 9. Let me just make this a little bit more clean. I know this part is 9 from here to here. I know if this is 5, this also needs to be 5, right? Because this is the radius. So out of 9, I have used 5. Now 4 is left. And I just told you in the previous slide, whatever is left has to be, these two are equal because the radius. So I have to equally split it. So the remaining 4 that I have from 9 has to be split into these two parts, 2 and 2. So from here also I can see small r is 5, capital R is 12. And I can use that to find my answer. So the correct answer in this case is option D. Now tell me this one was clear or not, because this was, I think, slightly tricky because of the 19 and 9. But I hope I made this perfectly clear that this portion from if TQ is 9, the remaining has to be 10, and they're both radiuses. So this 10 gets equally split into 5 and 5. Any questions, guys? Please ask. Though all of you got it, most of you got it correct, but those of you who didn't, I hope it's clear now why the answer has to be option D. If you have any questions, please ask. I can see a few no's. So if it's not clear, you can ask your question in the chat box. I'll be more than happy to answer it. Okay, about 90% of you said it's correct. Okay, Sumit is asking if the statement doesn't say US is the diameter, should we assume it to be the diameter? So that's a very common question which Sumit is asking. So first of all, understand if we are not assuming here anything. Like for example, if the diagram, in the diagram, if the two circles look identical, I will not think of it as identical. Okay, if the question does not mention US as the diameter, I will not assume it to be as a diameter. Okay, Sumit. So no assumption, especially in the data sufficiency question, no assumption at all. Whatever is given is what we are going to use to find the answer, nothing else. Okay. Okay, now let's do one coordinate question. We have about 5 to 7 minutes. I would want you to do at least one data sufficiency question on coordinate. So here's the question, and let me bring up the poll. Here's the poll, guys. It's a very interesting question. I decided to choose this because a lot of you are not comfortable dealing with slopes. So I thought at least one question on slope makes sense to do. This is the last question for the day, so give your best shot. Another 30 seconds, guys. I have a few responses, but I would like to get a few more. So those of you who are still trying, I would request you to put in your response. Okay, I'm going to end the poll now. Okay, so I have a pretty mixed response, almost equal split, not equal, but in the 30s basically, B and C. About 33% of you think that only B is sufficient, but about 37% of you think you need both of them. And yes, we have about 22 who think the answer should be E. So let's take this very quickly. This is a difficult one, and I'm going to show you a few diagrams in this case, because in questions like this, it's important that you're able to make the right inferences and draw the right diagram to get the answer. Okay. So first thing first, when you read the question, you'll notice that here they are saying that the line L1, L2, they lie in the XY coordinate plane, which is a pretty standard line, and they meet at a point n, 1. Where n is greater than 1. Now, this is very important, guys. This is very important where you need to make an inference. Let's say if n is greater than 0, what does that mean? What does that tell me? Where is the line meeting? Can anyone tell me? Can anyone tell me if n is greater than 0, where is the line meeting? A very small inference, but I think an important one. Two lines meet means they're cutting each other. Right. So they are meeting in the first quadrant. That's good in Q1. So that's a very important inference that you should be able to make after reading it. So I don't know how the line needs to be drawn first of all, but till here I know they have to meet somewhere in the first quadrant, which is Q1. Okay, good. Now, if both the lines, slope of both the lines are the same sign. Now, what does that mean? It means the slope is either both positive and the slope is both negative. And I'm going to talk about it, so don't worry about it, okay? But these are two inferences that you should be able to make, that they're meeting in quadrant 1 and the signs are the same. So both will be positive or both will be negative. We cannot have a case where one of them is positive and one of them is negative. So those of you who are trying to draw a line maybe like this and this, where one is positive, one is negative, you were making a mistake. Okay, I'm going to talk about it if this seems Greek and Hebrew, don't worry about it. Okay, question is asking is, I need to find out whether the slope of L1 is greater than L2. Now, let's talk about slope first. Okay. Now, how do I figure out when the slope of the two lines are positive? Now, the slope of lines are positive when the angle that you have is basically less than 90 degree. Okay, then in that case, we call the slope is positive, and it's not shown in the diagram. So I just want to show you, tell you how do we calculate slope. Now in GMAT, you're never going to be asked slope is basically tan theta. Don't worry about this trigonometrical thing. They're never going to ask you about tan or anything. What you need to keep in understand is that slope basically depends on the angle. And if the angle is basically, now notice a line makes two angles. One angle it makes like this. One angle it makes like this. Which angle do you consider as theta? Well, keep in mind, you always make an angle with respect to the x-axis. So if this is your x-axis and this is your line, okay, and let's say this is your y-axis, then you always move in the anti-clockwise direction from the x-axis. That is your angle, anti-clockwise, this way. So if I have to talk about the slope, I'll say my slope, my theta for this line or angle for this line is this one. Same for this. If I'm looking, I'll take the x-axis, I'll move from the x-axis and go like this and say this is the angle. And as long as the angle is less than 90 degree, the slope is positive. I hope this part is clear. Please mark yes if this is clear. Let me bring up a poll very quickly. If this is clear, please mark yes. These are small things, but very important when you're making when you're solving questions like this, because you have to draw diagrams to get the answer. So whenever the question says two lines are positive, as the slopes of two lines are positive, these are the kind of lines that you'll draw where the angle is less than 90 degree. Okay. And also keep in mind, if the angle should be less than 90 degree, that's fine. But the one with a bigger angle will have a greater slope. So for example, if this is 70 and this is 60, the one with 70 will have more slope. Okay. So in this case, if you notice, if I mark this as L and this as M, okay, I can see that this angle is greater and this is less. So I can say slope of line L is greater than slope of line M. Is this part clear? Again, let me bring up a yes or no poll because I don't want to explain everything and then figure out it isn't clear. Is this part clear? More angle, greater the slope. Keep in mind that the angle is less than 90 degree. Is this clear? Okay, good. The other case is where both of them can be negative, right? The slopes are both negative, and this is how you draw it. Okay. Notice when you're making the angle, you'll again make it in the anti-clockwise direction like this. This is the angle. This is the angle. Okay. Here the angle is greater than 90 degree. Okay. Slopes are negative, but keep in mind, just to simplify your life, keep in mind more angle, more the slope. More angle, greater slope. So in this case, notice line L has more angle here. it is negative, but the slope of line L is greater than line M. So in the exam, if you don't want to confuse yourself, there are two things keep in mind. Number one is how do you get a positive slope and a negative slope? That's one thing that you need to keep in mind. I hope this is clear. You get a positive slope when the angle is less than 90 degree. You get a negative slope when the angle is more than 90 degree. The second thing that you need to keep in mind is more angle or greater the angle. So if theta1 is greater than theta2, then obviously the slope will be greater for theta1 than it will be for slope theta2. And I'm talking about this, keep this in mind, that I'm talking about this when I know the sign is same. Okay. When I know the sign is same, please, this is very important. So for example, if one of the angle is 30 and the other is 120, don't go about saying ki, hey, more angle, more the value. No, don't think in this way. Make sure that both of them are positive, then the second one is valid. Both of them are negative, then the second one is valid. Obviously, one is 30, one is 120, then this angle is positive, this is negative. So this will be greater than this, just to make this very clear. But to declutter everything, this is how you need to remember. To check whether slope is positive or negative, less than 90, positive, greater than 90, negative. Okay. If both the slope of both, if the sign is same, both are positive or both are negative, then the one with the greater angle will have a greater slope. Okay, so I've tried to simplify it as much as possible. If you're able to remember these two inferences, making diagram in the exam and making the inference would be easy for you. Okay, now let's take up the statements. Now there's nothing else we can do. So we'll start off by taking the first statement. The first statement is that the x-intercept of line L1 and L2 are positive. Now there's another thing which I want to talk about is the intercept. I'll draw it here only. Intercepts are basically these points. So the x-intercept is this length basically, and the x-intercept is this length. Okay, y-intercept is basically this. So the y-intercept for this would be this, and the y-intercept for this this line would be this. So the point basically where they are cutting. So if they are telling me that the x-intercept is positive, all you need to do is draw one case. The way I've drawn it here. Notice that the x-intercept is positive. Okay, it could be anything. I don't know what the value is. It could be 1, 0, 2, 0. I don't know. But I need to draw a diagram where the sign is the same. What are the things that I'm taking care of? I'm taking care of this part. I'm making sure both the sign is same. So in this case, I've taken a case where both are positive. Okay. I'm making sure I'm satisfying the statements that the x-intercept is positive. So I've drawn the two lines. But do I know in this case which one is L1, which one is L2? Can anyone tell me? Do I know which one is L1, which one is L2? You can put in your response in the chat box. Do I know which one is what? Which one is L1 and which one is L2? I've drawn two lines, both positive. I've drawn the x-intercept. But do I have any idea which line is? No, Mark, that's absolutely correct. We don't know. We cannot be sure which one is positive and which one is negative. Since we don't know that, we cannot get the answer. Why can't we get the we cannot get the answer? Because it's quite possible that this is L, this is M. They are L1, L2, right? I've been saying L and M all along. Let's say this is L1, this is L2. Now, if this is L1, this has a bigger slope than this L2. So if this is the case, then L1 will be greater than L2. But the opposite is also possible. So they can switch also, right? If they switch, the answer will switch. Since I don't know exactly which one is what, I will not be able to figure out whether the slope of L1 is greater than the slope of L2. So this statement is not sufficient. So the answer cannot be A or D. Now, what is the learning here? See, the learning here is that since I know they have the same sign, and since now you know how to draw, lines when both are positive, both are negative. In the exam, you can draw these lines very quickly and make the inference. You'll draw two lines which are positive, and you can say L1, L2, no, so this is not sufficient, and you can very quickly move the next case. Now, this is statement 2. I drew the diagram beforehand because, as I told you, it's very difficult to draw diagrams for me. So it's better to have it in front of me. Now, in statement 2, notice what is given is that the y-intercept of L1. So now they're specifically talking about each line, which is very good for me. Okay, they're telling the y-intercept of L1 is less then the y-intercept of L2. I know that they are both positive or both negative. So I'll try and draw two lines, okay, where both the conditions are satisfied. The signs are the same, slope, so both positive. This is both positive, where the signs both negative. And I'm trying to ensure that the y-intercept is less. So notice my line A, this is L. Notice this is y-intercept. I should have written L1, L2. Apologies for that. This is L1, this is L2. Okay. And L2 is here. Now notice the y-intercept is negative. And here it is positive. This is the y-intercept which is positive and this is negative. Now keep in mind, keep this in mind that when I draw this, after satisfying the condition, I can see that L1 is this one, L2 is this one. In this case, I can see the slope of L1 is greater than the slope of L2. Okay, I hope this part is clear. If this is clear, I'll talk about the next one. Let me bring up the poll. Is this part clear? I made sure I satisfy both the condition. Number one, the y-intercept of line L1 is less than L2. I ensured that, as you can see in the diagram, if the y-intercept of L1 is negative and this is positive, so this is satisfied. They have the same sign. I ensured that both these slopes are positive. And in this, I can notice the line L1, which has a lesser slope, a lesser y-intercept, has a greater slope. So in this one, I can say the slope of L1 is greater than the slope of L2. Okay, very good. I can see it's clear to all of you, which is perfect. But I should not stop here. Now, some of you might say, hey, this has to be correct. No. Keep in mind that there are two cases, both plus, both minus. So you should draw a case also where both of them are negative and check it. And now you know how to draw it. So it won't take you a lot of time to make these two drawings. Make two drawings. This is the negative drawing where you can see the angles are more than 90 degrees, so they are negative. And make sure that this condition is satisfied. Notice L1 is less than L2. And this case, notice L1 has a greater angle here. Notice here it has greater angle. So it will have a greater slope. In this case also, I can see L1 is greater than L2. So when they are both positive also, and when they satisfy both the conditions, same sign and y-intercept less, and when they are both negative also, when they satisfy both the condition, I can see in both cases, slope of L1 is greater than slope of L2. And since slope of L1 is greater than slope of L2 in both the cases, I can say the correct answer in this case has to be option B because I'm getting a unique answer. So one final time, guys, I'm bringing up the poll. Please let me know if this is perfectly clear or not. If you have any doubt, please ask in the chat box. If this is perfectly clear, please say yes in that. Okay, I can see all of you are saying yes, which is pretty good. So guys, with this, I'm bringing this session to an end. I hope you like the session and you learned a lot from this. A slope question, frankly, in coordinate is a very common kind of question that you'll come across in the exam. So it's like really, really, really important for you to know this.